And this next session is a really interesting one, thinking about site speed for content marketers. So if we could have a big round of applause, everybody, for Tom Bennet.
Okay, can you hear me? Yeah, good. Hi, everyone. My name's Tom. I work as senior consultant at an agency called Built Visible in London. And today, I'd like to talk to you about site speed. We're going to be discussing why it matters, how you can measure it, and most importantly, we'll be doing a live demo to demonstrate what you, as marketers, can do to have a measurable impact on the speed of your content. Now, first question should be fairly easy to answer. Why does site speed matter? You would need only ask your users. There are countless studies demonstrating the irrefutable connection between site speed and various different KPIs, from organic landings to bounce rate and so on. So it's something that your business needs to be aware of. Just a couple that I've picked out here. The team at Walmart Labs found that for every 1 second they improved the load time of their site, they experienced up to a 2% conversion increase. Similarly, the team at Firefox, when they reduced the load time of their page by just over 2 seconds, downloads of that browser actually went up by about 15%, which equates to 10 million downloads of that browser per year. Google is, of course, very aware of how important site speed is to users, and that is one of the reasons why, in 2010, they added site speed to their algorithm. Now, key point to consider here is that Google doesn't measure site speed against some concrete benchmark. You're instead measured relative to other sites. So it's not sufficient to occasionally consider site speed. It needs to be an integral part of your process if you are to stay ahead of the curve, because you're being measured against your own competition. So the question then becomes, as a marketer, what can I do about it? There's misconception about site speed that you have to be an expert back-end web developer experienced in things like server configuration to have any real impact. And that's simply not true. I like to remind people of the so-called performance golden rule, which was first observed by Steve Souders, who was head performance engineer at Google. 80 to 90% of the end user response time is spent on the front end of a website. So if you're optimizing for performance, it makes sense to start there. What kind of things does the front end comprise? This is a chart published by httparchive.org. It's revised every month, and it shows the average number of bytes per content type per page. So you can see that as of April 2016, images comprise well over 2/3 of the weight of an average page, which comes in at a total of just over 2.3 megabytes. Now, content marketing, which tends to be very rich and visual, often has interactive elements, presents even more of an opportunity in this regard for optimization. So this is what we're going to do right now. We're going to audit and fix a piece of content marketing, which I've prepared for this presentation. It was tempting to go Bill O'Reilly here and do it live, but that is a recipe for disaster on a stage like this. So we're going to do the next best thing, and we're going to look at recordings of our site's performance, and then watch the incremental improvements as we make them. So here is the piece of content I have prepared. Following the recent trend, it's a piece of long-form guide content. It has some nice full-width imagery, a little interactive tabbed widget, some sharing buttons, all the kinds of things you might expect to see in a generic piece of content produced by an agency today. In terms of how it's built, I've tried to keep it as middle of the road as possible. So I used Bootstrap, which is, of course, one of the most popular front-end web frameworks in the world. I used the initializer service, which generates a site template based on the HTML5 boilerplate, which is powered by Bootstrap. This, of course, includes jQuery as standard to power any interactive elements. And then finally, picked out some imagery from StockSnap. Given that our agency is based in London, specifically in Shoreditch, I picked out the most hipster images I could find, of course. How are we going to measure our site? There are loads of analysis suites out there, but we're going to be using GTmetrix, which is a great one to start with. It provides recommendations based on both Yahoo's YSlow and Google PageSpeed tools. and then provides recommendations for how you can fix those issues. So it's a great one to test out. So let's test our page, see how it does. It's not great. We've got an F on page speed and a C on Y slow. Page load time is just about to hit 4 seconds, and the total weight of the page is just over 4 megabytes. Now, the actual load time, of course, will vary depending on various factors, latency, network, and so on. So our main goal is going to be getting that page weight down as low as we can. Now, we've established images are often the biggest opportunity, so we'll start with the images. We're going to dive straight into the web inspector in Chrome and have a look. So our two side-by-side images here, you can see that on a large 1080p screen like we're testing on, they're displayed at a maximum of 420 pixels wide. And yet the source files are 1024 pixels wide. Now, that doesn't sound huge, but 1024 pixels is realistically double what we actually need. As is often the case when a microsite like this is being prepared outside of a proper development pipeline, as content marketing so often is, the images have just been dropped in with very little in the way of optimization. They are JPEGs, which is the appropriate format for photos in general, but they've been saved at 95% quality, which is almost always overkill for the web. 70 to 80% compression is generally yields no perceptible difference in quality, and yet the file size can be a lot smaller. Another image has just been dropped in as a PNG. PNG is, of course, a lossless image format. The file size is correspondingly higher, and it's generally not ideal for photos like this. So the fix for all of these is the same. We want to export from the source files in an appropriate format, an appropriate compression level for the image's placement on the page. Simple as that. And once we've done that, see what impact that has on the load time of our site. Get it down by over 70%. Page load time comes down by over a second, and the weight of the page is down to just over 1.2 megabytes, which is a great start, a huge improvement. A few things to consider when you're working with images on the web. Format and compression. In general, you want to be using JPEG for photos or images with smooth gradients, lots of colors, and then PNG for images with fewer colors or with transparency, like logos, for example. In terms of compression level, you want to balance file size and aesthetics. So 70 to 80% compression for JPEGs normally, like I said, and consider other services as well, like Tiny PNG. This is a way of optimizing a PNG you've already exported by stripping out metadata and optimizing the color palette and that sort of thing. Dimensions, you can't just drop a wallpaper-sized image into your page and expect it to perform well. Always calculate the width and height at which it's going to be displayed. And finally, there's a saying in web performance, which is the fastest HTTP request is one which is not made. So always consider not using an image at all. Avoid using images with text in them. Try to use an actual font instead. Wherever possible, use vector graphics, which are resolution independent and can be infinitely rescaled with no loss in quality and reused throughout your site in different contexts. And for supplemental effects, browser support for CSS effects is so good these days that you can just use CSS shadows and gradients and so on, which have a very low performance overhead, of course. And there are links in the footer which discuss all of these points in more detail, generally to Google Web Fundamentals, which is a great place to start. Next one is fonts. It's commonly overlooked. Like a lot of content marketing, we decided to use the free Google Font service. First, and most obviously, make sure you're not using or not calling all weights and styles of your chosen typeface. It's a very easy one to miss, because if you're testing in a modern browser, like Google or Chrome, like so many of us do, that browser will only download the weights and styles which are actually used in your style sheet. Whereas older browsers, Internet Explorer namely, will predictably download everything, which is called in your HTML. So if you see a line like that, calling all those different weights and styles, you want to audit that. Another one, which is commonly overlooked, is icon fonts. So let's take a look again at the sharing buttons we've got at the bottom of our page. You can see that they're powered by Font Awesome, which, in case you haven't heard of it, is a very popular icon font. Icon fonts They work in largely the same way as a regular font. It provides a library of about 600 icons, which can be infinitely resized because they're vector-based, like a regular font, and styled with CSS. And the benefits are pretty obvious. It's one file that you drop into your site, provides a library of 600 icons, no JavaScript required, and browser support is fantastic. It goes back pretty much to the dinosaur ages. The problem is this. It's when you hit getting started on the Font Awesome website, like most people do, you're given one line of code to put into your website. Now this calls a 20 kilobyte style sheet and an 80 kilobyte font file for the sake of, in our case, just 3 icons. Surely in the era of the modern web, we can do better. And in this case, an ideal solution is SVG. The scalable vector graphics format is perfect for icons. There's no noticeable difference in terms of appearance or behavior. Browser support is very good, goes back to IE9 and all modern browsers. And as you can see, the savings in file size in this case are huge. And one of the reasons for that is that we can encode our SVGs inline in the HTML. This is all the code that is required for our 3 icons. We don't have to make any additional requests. Everything is right there. There's a link in the footer to CSS tricks, which examines some of the use cases between icon fonts and SVG, which I recommend you read. It's very interesting. So we've optimized our selection of Google fonts. We've swapped out our icon font for SVG, and what's the result? Get our page load time down by about ½ a second, 100 kilobytes shaved off our total page size, and 2 fewer requests, which is not bad progress. Things to consider with fonts: be very strict with typefaces, weights, and styles. Always weigh the aesthetics against the added requests. Try and consider how many are necessary. If you're calling a font purely for a logo, for example, services like Font Squirrel will let you customize a font file which contains only the characters you need, which in some cases can save you a lot of added weight. And hosting, if you're using Google Fonts or Typekit or any other external font provider, they'll distribute their fonts via a CDN, and there's a greater chance that your visitor will already have that resource cached. And if they don't, it's served via a high-speed CDN. Next is scripts and style sheets. Now, you want to be auditing each and every request that your page is making. So we'll take a look again at that little interactive widget in the middle of our content. It's powered by jQuery, as is standard with Bootstrap. We'll put aside the question of whether or not it's strictly necessary to use jQuery in a situation like this, and instead we'll consider the version of jQuery we're using. There are 2 branches of jQuery which are developed concurrently. jQuery 2 has the same API as version 1, but like Microsoft, it doesn't support the legacy Internet Explorer versions 6, 7, and 8. As a result, we can use jQuery 2 rather than the bigger jQuery 1. Also, and this applies to all JavaScript libraries which you're using on your page, make sure you're not using the development versions of any libraries on your live site. You want to be using the compressed production versions. I've seen repeated examples of pieces of content marketing out there using the development version of jQuery, for example, which is huge. That's 3 times the file size. So keep an eye out for that. Speaking of development versus production versions of libraries, that brings us on quite nicely to subject of minification and concatenation. Minification is essentially the process of stripping out all the unnecessary or redundant data in a script or a style sheet without affecting how it's interpreted by the browser. And then concatenation just means joining them together. So instead of making 3 requests for 3 separate style sheets, we can make 1 request for a single compressed file. Both of these, minification, concatenation, should be a part of your build process. And there's a link, again, to Google Web Fundamentals in the footer, which explains this in more detail. So we've selected the appropriate versions of all of our JavaScript libraries. We've minified and concatenated our scripts and our style sheets. And what impact does that have? Reduction in page weight by about 50%, which gets the load time down to 2 seconds, which is a good improvement. 1 fewer request being made as well. A few things to consider with scripts. if you're preparing a piece of content marketing for a client and someone says, where are the social sharing buttons? We need some social buttons. Put them in. And you find the first plugin you can, you drop it in, and it works, and you forget about it. Things like that, which you haven't audited, should be the first to go. They can add a huge amount of overhead to your page. Minification and concatenation, make them a part of your build process. Make sure you're using the appropriate versions of all of your scripts. Caching, as with fonts, if you call jQuery from Google's hosted libraries CDN, for example, it increases the chance that the visitor will have that resource cached by their browser. And finally, placement. There's the link in the footer introduces the concept of the critical rendering path. I wanted to explore this in more detail, but my slide deck was too long. But suffice to say that the position of a script in your HTML matters, because CSS and JavaScript are what are known as render blocking resources. And that means when the browser is parsing your HTML, when it encounters a script, it has to stop, request the script, download it, and execute it before continuing to parse your HTML. It will have to download the resource eventually, but if you botch the placement of your scripts or your style sheet, you can completely ruin the user experience of your site. So be sure to investigate your critical rendering path. Next is gzip. I know I said we'd be focusing purely on front-end considerations, but gzip is such an easy win that you'd be foolish not to use it. Gzip is a piece of software which runs server-side. It compresses your website's files algorithmically, and they then get sent down the tubes at a reduced size, and the browser unpacks them at the other end. It works best on text-based files, so scripts and style sheets, that sort of thing. So we'll test it on our Bootstrap CSS file. This has already been minified, bear in mind, so it's already compressed. But when we enable gzip on our server, you can see that we get the size down by 83%, down to 17 kilobytes, which is a huge improvement. In terms of cost to implement versus benefit to performance, gzip is one of the best optimizations you can make. Some servers do implement it automatically, but others don't. So it's always worth checking that the file types which benefit from compression are being compressed. Implementation varies depending on your server, but there's links in the footer for Apache, Nginx, and IIS. We have enabled that on our piece of content, and the result is we shave about 30% off the total page weight, and we get almost half a second off the load time of the page. Compared to where we've come, that's almost a 90% reduction in the weight of our content, with no noticeable difference in appearance or behavior, except the increased speed, of course. Our page speed and YSlow scores have also improved from an F and a C to a B and an A, which is minimal effort and quite a lot of return. One final consideration which any discussion of site speed would be incomplete without, and that is mobile. Mobile does require special consideration because it's now the primary means by which millions of people access the internet. You're dealing not just with different screen sizes, but with different aspect ratios, different network capabilities, broadband versus 3G, browsers with different feature sets, and all of these things affect speed. So to pull out just one example of potential mobile optimizations which we can apply to our long-form piece, let's take a look at that header image. If we shrunk that any further, users on 1080p screens would get an image file which is smaller than is ideal. How can we serve an appropriate resource to each of those devices based on the screen size? Well, the answer is the responsive image syntax with source set. This allows us to provide URL references to several different versions of the same image, provide some supplemental information just right there in the HTML, and then let the browser choose which one it's appropriate to download based not just on screen size, but on the network conditions, for example. It's now supported natively in WordPress 4.4, so be sure to check it out. Links in the footer there. So where does that get us? We were just over 4 megabytes with an almost 4-second load time. Our optimized version, which will benefit mobile, of course, gets that down to 445 kilobytes. But when we test on a mobile device with responsive images implemented, we get that down to the all-important 1-second load time, and our page weight is cut in half again, just by serving the appropriate image file to our mobile device. Final point from me is on challenges which you will likely face raising awareness of performance within your organization. Doing so is more often a cultural challenge than a technical one. Lara Hogan wrote about this at length in her fantastic book, Designing for Performance, which is linked there in the footer. Site speed is something which everyone in the content production pipeline needs to be aware of, because otherwise you simply won't spot opportunities. To give one example, again using our dummy site, let's say that the purpose of this piece of content is to funnel users to a more commercial landing page. We'll give it a call to action button. This may be backed up with data from GA, that we have a very predictable navigation path through our site. In a case like this, you might consider implementing rel prefetch or rel pre-render, which is a way of requesting resources which are probably going to be needed based on the user's next click. It's a similar technique to what Google does when it's confident which result in the SERP you're going to click on, and it makes the next page load almost instantaneously. Spotting opportunities like this require you to look at your content more holistically, making performance a forefront concern. This is why at Built Visible we've made site speed something which all of our consultants are trained in, because being able to speak the same language as your developers is never a bad thing. And that brings me to the end. We've really just scratched the surface of what is a huge discipline today, and there are, of course, exceptions to every rule. So I would encourage everyone to follow the links in the slides, read up on the principles behind site speed, because it's a fascinating subject, and it is possible to make huge gains just by being aware of the biggest opportunities. So thank you very much for listening. I hope you found that useful, and enjoy the rest of your day.
That was pretty practical, wasn't it? Really good. Really enjoyed that, Tom.